Hello, I'm Dr. Mercedes Ruiz Brunner, and today I'm going to present the article Development of Equation and Software for Estimating Weight in Children with Cerebral Palsy. The authors of these articles were Ruiz Brunner, Thierry, Butler, and Cuestas. The institutions that support us were the National University of Córdoba and the National Research Council, CONICET. Children with cerebral palsy tend to present lower weight and shorter status than typically developing children. In low and middle income countries, undernutrition tends to affect more than half of the children with CP. Antropometric information in children reflects their general health and is used to assess nutritional status. Weight is an essential measure to assess growth. In children with CP, obtaining weight by direct measurement becomes more difficult owing to their lack of balance and their motor compromise, as they find it hard to stay still on a regular scale. These difficulties increase in low and middle income countries where wheelchair-adapted scales or even regular scales are not available, whereby weight cannot be recorded. Mid-upper arm circumference is a segmental measure that has been proven to indirectly assess growth and changes in caloric and protein intakes. This segmental measure uses the fat, bone, and muscle area of the arm as an indirect measurement to evaluate body weight. The World Health Organization recommends the use of the mid-upper arm circumference as a measurement that, alongside with weight for age, can be a diagnostic criterion for severe acute malnutrition in typically developing children. Yet, this segmental measure has not been studied in children with CP. In a previous paper, we developed equations to estimate weight in Argentinian typically developing children. In this study, it was observed that mid-upper arm circumference was the best segmental measure to estimate weight combined with variables such as age and sex. To our knowledge, there are no equations available to estimate weight in children with CP. The aim of this study was to develop an equation to estimate weight using segmental measures in children with cerebral palsy from 2 to 19 years of age, and then to create a software tool that helps to use the equation in a clinical practice. A cross-sectional study design was used to collect data about weight and height as well as mid-upper arm circumference. The participants were children with a confirmed diagnosis of CP from 2 to 19 years old. Those with genetic or metabolic syndrome that could have or had affected growth were excluded. Children from 17 rehabilitation and therapeutic educational centers that specialize in motor rehabilitation from 5 cities in Argentina participated in the study. Of the 433 potential children, 381 agreed to participate and were available for the data collection dates. The protocol of the study was registered in clinicaltrials.gov. Informed written consent was obtained from all participants and their parents or legal guardians, and had the approval of the Ethics Committee. Weight was obtained in kilograms using a wheelchair scale or a digital scale depending on the child's ability. Mid-upper arm circumference was measured using a flexible and inelastic measuring tape SECA on the less affected side of the body. For those children who were able to stand, height was measured with a portable stadiometer. When direct height could not be obtained, it was estimated using published equation for children with CP using knee height. Nutritional status was defined on the basis of weight for age, height for age, and body mass index for age according to sex. Measurements were converted to set scores on the basis of growth chart from the World Health Organization using WHO Anthroplus software. The Gross Motor Function Classification System reports 5 levels of motor function in children with CP according to international guidelines. The MFCS levels were classified by physicians and physiotherapists. Age, sex, and other characteristics were collected from clinical reports. This included information about type of CP and tube feeding. To identify the relation between weight and the segmental measure middle upper arm circumference, Pearson correlation was used in the normal variables and Spearman correlation in the case of non-normality, and R-square determination was calculated. Linear regression models were performed to develop the equation calculating R-square, adjusted R-square, and the root mean square of the error. A p-value less than 0.05 was predefined as statistical significant. To analyze the degree of agreement between the observed and the estimated weight, Bland-Allman plots were made and the coefficient of correlation agreement were calculated. The average difference between estimated and observed weight was calculated with 95% confidence intervals. Data was used for analysis, and the software we created was developed using Java by the research team of our institution. Of the sample of 381 children and adolescents, 60.6 were male and 39.4 were female. The characteristic of the children with CP can be seen in Table S1 online supporting information. Middle upper arm circumference show a correlation of Spearman with the weight of 0.87 in males and 0.88 in female, both with a statistic significance. The scatter plots by sex are shown in Figure S1, online supporting information. No statistically significant difference were observed according to sex in weight and middle upper arm circumference. On the other hand, there were statistically significant differences in weight and middle upper arm circumference according to the DMFCS level 1 to 3 versus 4 and 5. To estimate weight, middle upper arm circumference was analyzed with different covariance to see which gave the best fit to the predict value. It was observed that age and GMFCS level were variables that best adjust the results of the equation to predict weight. The equations developed to estimate weight in children with CP were two, considering the GMFCS level. The equations are presented in Table 2. And the constant and coefficients of the final linear regression model are presented in Table S2 online supporting information. The confident concordance correlation between the estimate and the observed weight was 0.94. The average difference between estimate and observed weight in all children with CP was 119 grams. And the analysis according to GMFCS level showed that the average difference between estimated and observed weight in children with GMFCS level 1 to 3 was 250 grams, and the average difference between estimate and observed weight in children with GMFCS 4 and 5 was minus 20 grams. The Bland-Allman plots show that the estimated weight values predict observed weight values with reasonable accuracy. When we analyze by age group, the means and 95% confidence intervals of estimated weight and observed weight values did not show statistical differences through ages 2 to 19 years, as shown in Figure 2. A software tool was developed to calculate the estimated weight in children and adolescents with CP. The Weight Calculator CP is a free access tool that can be accessed online. The equations to estimate weight using meter upper arm circumference and the weight calculator CP software developed in this study are accurate for estimating weight in children with CP from 2 to 19 years of age. The only information needed is the segmental measure, age, and GMFCS level. In a clinical context, these equations will allow health professionals to easily estimate the weight of children with CP using only a flexible tape measure, especially in low and middle-income country settings where access to accurate scales is extremely limited, particularly wheelchair-accessible scale. The equations presented weight with a very reasonable estimation error. In this case, it is based on an Argentinian population of children with CP. Because of this, caution should be exercised when applying these equations to children from another ethnic group and when it is used at an individual level. At a clinical level, differences greater than 10 kilograms can be found in estimated weight with respect to observed weight in some children. For this reason, clinicians should be careful in interpreting individual weight estimation alone. The tools developed are simple to use, low cost, and can be widely distributed in similar populations. What this paper adds are equations that can be used to estimate weight in children with cerebral palsy via body segments. Weight can be estimated according to age and gross motor function. The average differences between estimated and observed weight was 119 grams. Acknowledgements and references are mentioned here and can be found in the article online. Thank you.